So let's factor x squared minus 4 first, right here. It's x plus 2, x minus 2, right? What is my LCD for this problem?
Here's what I found.
What's the LCD for this problem? Yeah, x plus 2, x minus 2. And you can remember what do we do next? Yeah, so you go to each fraction, whichever you're missing, you multiply the top and the bottom by that one, right? So for example, the first one I'm missing x plus 2 over x plus 2. A lot of time on the exam, people multiply the bottom, but they forget to do the top. I'll show you. So be mindful. The second one missing x minus 2, so x minus 2 over x minus 2. Parentheses around here too. And then the last one is okay.
I found this on the web.
My palm keep pressing that thing. Maybe I should have changed the rest. All right, so for the first fraction, I'm going to distribute the 2. So distribute the 2 in there. So I have 2x plus 4. Distribute the 3. Distribute the 3. So I have plus 3x minus 6. And then what do I do? Minus what? Minus x plus 1 or minus x minus 1? Minus x plus 1 or minus x minus 1? Yeah, minus, oh no, minus x minus 1, right? I'm sorry, plus 1, plus 1. You can distribute that negative. Very simple, again, very popular mistake. You can distribute that negative into each of those. Negative x, positive 1. And then x plus 2, x minus 2 on the denominator here. Combine like term. 2x, 3x, and then minus 1x. So that's 4x. Plus 4 minus 6 is minus 2. Plus 1 is minus 1. I don't think you can simplify any further, so just box it. It's done. Let me ask you, what's the domain of this one? What is the domain? Very good, right? You should be a pro at domain by now, right? Of course, on the exam, I'll ask you to write interval notation, right? But that's you to practice. But as far as I'm concerned, if I ask you right away, you should know. All right, one more. This one I'll do it with you. A little bit. It's not difficult. It's just something you might just look past. So if you notice that the denominator, they kind of almost right? So it's not commutative. If you have y squared minus 4, it's not the same thing as 4 minus y squared. So if I was you, I would change this into the same thing as this one. So this one I'm going to do like this. 4 minus y squared. I'm going to try to bring the y to the front. So switch the order, y squared plus 4. So far so good. Oh, I did just switch the order. Can I factor out -1? Remember what I say about GCF? You factor out including the negative one, right? So negative one, factor out will be y squared minus 4. Now it's somewhat the same, right? We'll plug it back, rewrite the first one, minus 6 over negative 1 y squared minus 4. Can I combine these two together to become positive? Yes, right? Don't write this down. If I have, say, negative 3/2, it's the same thing as negative 3/2. It's the same thing as 3 over negative 2. Right? So I can bring this one up for the negatives, become negative 6. Negative 6 is negative 6 is positive 6. Or so here I'm just going to rewrite it as y squared minus 5y over y squared minus 4 plus 6 over y squared minus 4. The negative is gone. Use that. Now you can add across because we have the same denominator here. Y squared minus 5 squared plus 6. Is it factorable? Let me factor the bottom is y minus 2, y plus 2. Can someone factor the top for me? It's just, so can someone factor the top? It should be easy. Thank you. Why? Slower. Close. Y plus 6. Y minus 1. Okay. No. No. Let's see. Negative 6 and minus 1 is negative 6, right? You want positive 6. So maybe you pick a different pair. Try different pairs. Negative 3, negative 2, yeah. So negative 2 times negative 3 is positive 6. Negative 2y, negative 3y is negative 5. Yeah, you can always double check, right? You can always double check. And now I can factor, I can simplify that one. Y minus 3 over y plus 2. Do you have any question so far? Not, you guys tried the last one? Again, I suggest you change this one into y minus 2. It's the same way I did up here with the 4 minus 5 squared. You do right. I think you think the right. Thinking right. Presentation. Yeah.
Oh, mine. There it is. Okay, that, okay, that's what Thank you. You're good, you're good. I'll put it.
A lot of you be able to practicing. Just be careful when you don't skip step. Do one step at a time. So 2 minus y, it's the same thing as minus y plus 2, right? Rearrange the order. Now you factor out -1. When you factor out -1, everything changes size. Rewrite this -2y minus y over, we'll talk about that later. And then rewrite the top. The bottom is -1 times y minus 2. The -1 and the -1 combine to become positive, right? So y minus 1 over y minus 2. So those two green things to combine to become positive, and then you rewrite. The reason I leave the blank for the first denominator, because I want you to factor it as well. So 2y minus 2 over, oh, I write large, I'm running out of space soon. Can someone factor this for me? Bless you. All right, y minus 2, y plus 4. Thank you. LCD is, yeah, so you're missing, maybe I put the parenthesis like this. So you're missing y plus 4 over y plus 4 here. You're gonna write twice. You have to write twice. That's the correct way of doing it. So now you have the same denominator. All you do is adding across 2y minus 2. Distribute that second one. Y times y is y squared. I'm going to put the parenthesis here, okay? I'll remove it later. Plus 4y minus 1y minus 4. The reason I do the parentheses now for you, because here we have a plus. So say in the beginning you forgot the parenthesis, it's okay. Hypothetically, it was a negative. Hypothetically, it was a negative. Then you have to distribute. When you remove the parentheses, you have to distribute everybody inside. Even this one. change the size. But plus, we kind of just ignore it. So equal, simplify this, what you got? I got y squared. Give me a second. I gotta move it up a little bit because I'm running out of space. There we go. I can go down a little bit more. I'm going to write things in descending order, meaning from higher power to lower power. So y squared first, and then I got 2y plus 4y is 6y minus y is plus 5y, negative 2. Negative. Oh, was it negative? Oh, thank you, thank you. Negative, negative. No, you don't have to. The top, you just kind of combine them at the end. You may, but the first thing first is just to combine them first. Oh, so everything changed. So negative. Did I mess up anywhere? Is that it? Okay. I was hoping I can simplify more. Y squared plus 2y. Oh, so y. Okay. So it's just positive y, right? Okay, all right. All right, factor that for me. Should be able to factor like a pro now for the one with the coefficient 1. Good. Mhm. And then you can simplify that one with that one. So your final answer is y plus 3 over y plus 4. Makes it 6. What we get, right? Positive 3y minus 2y, so positive 1y. Yes. 6 and negative 1. What? Like that. So okay, you got negative 6, but then you have 5y. We want 1y. I messed up in the beginning. It was in 5y. Oh. Yeah, I fixed it. Sorry. Okay. Yeah. Anything else before we move on to the new objective? Please ask. Okay. All right. So this one is different. Maybe you see this in 662. It's called complex fraction. That means you have a fraction on top of another fraction. Like a mini fraction on top of another mini fraction become a big fraction. So let me remind you, if I have, say, don't write this down. If I say 5 over 3, it's the same thing as what? 5 divided by 3, right? And then you can put the 1 here. And then what do? 5 times 1 over 3, which is 5/3, right? To go back to the beginning. Same thing here. I'm gonna reduce this into a simple fractions by doing division. So 3/5 divided by 9 over 10. And when you divide something, you flip multiply. So 3/5 times 10, 9, which is, see, that one is 1, 3. And this, oops. And this one is 2, 1. So 2/3. You can see the green one, sorry. 2/3. So the formal definition of a complex fraction is that the numerator and denominator contain the rational expressions. That's all. Maybe I should have put plural expressions. Plural. For example, I'll give you a few examples. Say I have x over y over z over t. So the numbers, I do letters now. Or maybe I'll make it a little bit more, slightly more complicated, just slightly, but it's the same family. X plus 1 over y minus 2 over x over y minus 1. It's still one fraction, right? This is considered one fraction, one fraction, one fraction, one fraction. So it's just slightly a bit more, but it's not too bad. Now the bad boy, the harder one is look like this. Something like that. Maybe a 1 y over. Maybe oh. Maybe I'll do y over x. Why is it hard? Because you have a multiple fraction now on top of multiple fraction. So we can have two cases. The one where the easy case is D2, and the harder one will be this one. For this one, I'll show you two ways of solving, simplifying this. Okay. And up to you whether how you want to pick which way you want to do on the exam. All right, so let's do the easy one first. Simplify complex fraction by writing as division. So this one I rewrite it as 3a over b minus 5 divide b squared. Can I simplify this one right away? B plus 5, b minus 5. Okay. Then you flip multiply. Parentheses here as well. And now you can simplify. So what's left is 3a times quantity of b plus 5 over b squared. And then you're done. Please do not simplify this. I know I'm tempted. But why you cannot simplify? You can remember why? Because it's being attached to something else. If it's subtraction from minus, you cannot do that. What's the domain of this fraction? Someone else beside her. What's the domain of this fraction? I can take anything but what? 0, right? 0. Anything but 0. You guys try number 2. Okay, I'll do number. I don't know why I said 4 here. It should be 3. You guys try number 2. I don't know 4 with you. Hmm. Oh, yeah. Oh, sorry. We have been signed out because. Anyone got the answer? So you write like that, right? You write like that. Can someone factor this for me? Perfect, thank you. And all you do is simplify. That one with that one. And this one with this one. So I have what, 2, 3? 2 and 3 here. So your final answer will be 2 over 3 times quantity of D plus 3. So that's why I call this is easy one. Yes.
If I put on the bottom, if I put my 3 on the line, plus 3, so if I put D plus 3.
That's fine. Yeah. That's fine. All right. Okay, 6-1. You shouldn't try yourself, but I'm going to show you 2 ways of doing this. Yes.
I had a question.
Go back. Okay.
What was I could do with the D plus 6?
Oh, you simplified it. So. Yeah, it's 1. Right, it's 1. But thank you for asking. Anything else? All right. So for the more complicated one, I'm going to show you two ways. Okay. The first one is using the traditional one we've been doing, writing as division. The second one is using the ultimate LCD. It's faster. Some people don't like it. It's kind of like a guess and check kind of thing, but it's better than guess and check, right? But I'll show you 2 ways, whichever way you want to pick for the exam, fine by me. Okay, so for this one, I'm going to focus one fraction at a time. I'm going to focus on for the numerator first, and then the denominator. What is the LCD for the numerator? Yeah, BW. So the BW. I'll do it like this. So this one missing W over W. This one missing V over V. So I have 2W plus 2V. I know my V look funny. Over WV or VW, doesn't matter. Now let's take care of the bottom. LCD for the bottom. Yeah, so the first fraction is missing W squared over W squared, V squared over V squared. So I have what? I have W squared minus V squared over W squared, V squared. And now you can do the division thing, right? So I got 2W plus 2V over VW. Can I flip it right now, or should I do division? You can flip, okay, I can flip it. Times, I'll do division, just for the sake of the note, okay? divided by W squared minus B squared over W squared V squared. I'm gonna flip it. And then factor at the same time. For the first one, I can factor out the 2, right? So W plus V. The denominator stay the same. For the second one, I can factor like W minus V, W plus V. Oh, I didn't flip it yet. My bad. Just I should have flipped earlier so I don't forget. Sorry. It should be W squared V squared here. I'm so sorry. W minus V, W plus V. I said I flipped, I forgot. All right, simplify. This with this. What else? What else? Yeah, this one and one of this, right? One of this. I guess both of you, this one. So what's left is 2WV over W minus V. That's it. Yeah. Do you have any question for this one? Yes.
Wouldn't you get rid of like the powers, like the second power, be it the second power?
I did. So this one, you don't have to do it, you don't have to write this down. So this one right here, it's the same thing as what? W times V times V, right?
Oh, I see.
Yeah. Mhm. Should I leave it like that? All right, so this one, now we're gonna use the ultimate LCD, a little bit different here. I'm not gonna do one at a time anymore. I'm gonna do all of them in one shot. So the way I do this is I'm gonna try to figure out what is my least common denominator for all of these little mini denominators. So between 4, 9, 6, 12, what is the LCD? 36. Very good. So what I'm going to do is I'm going to multiply the top by 36 over 1. Same thing with the bottom, 36 over 1. So basically, I multiply by 1, right? I didn't change. This divided this is 1. And now I distribute. So equal 36 over 1 times 1/4 is careful. These are I know you know how to do it, but for some reason on the exam you guys get nervous and then you do things wrong. So it'll be 9, right? Not 1/9. Careful, 9. 36 over 1 times 1/9 is 4. So 13. Now the denominator 36 times 1/6. 36 divided by 6 is 6. And 36 divided by 12 is 3. Done. That's what I say is fast. Let's do one more and then you tell me which one you like. Either by division or by the ultimate LCD. Right. Same procedure. I'm gonna account for the LCD for the little denominator. Don't look at the numerator. Nothing to do with the LCD. Between R squared, T squared, what's my LCD? Yeah, thank you. R squared, T squared, or R squared, T squared over 1. I always do that. So multiply the top by r squared t squared over 1. The bottom is r squared t squared over 1. So basically you multiply by 1 and then you distribute. Someone tell me what the first fraction will be. This times this.
R squared plus T squared.
To the answer, the what? If you doubt yourself, write it out. Well, that's a 2, right? There's nothing to do with the 2. There's a 2. Can I simplify the r? Can I simplify the r? Yes, right. I have r squared on the top and r on the bottom, so there's one r left. Can I simplify the t squared? No, right? So just rewrite t squared. But the main thing is no more denominator. If you still have denominator, there's something wrong. Okay? Someone else for the second one. Very good. 2r squared t. Someone else for the denominator. First one. This one. Let me cover this. Cover that. What you got? Yeah, t squared. You can cover your finger. So t squared. And then minus r squared. That's it. That's it. If you doubt yourself, you go ahead and like write it out, right? Write out. Can I factor something out for the top? More than that. So let me help you do the bottom. Is top is 2. What else? What else I can factor out? Yeah, 2RT. Right? So what's left is T plus R. Did you guys see that? This one gone. Which one you like better, this method or the division? Yes, division.
So that's the question.
Mhm.
So lowest common denominator, lowest common denominator,
All 4. Yeah.
and then
You multiply top and bottom by the LCD.
okay,
I recommend over 1. Just when you do fraction, it's just easier. Yes.
So on like the final answer, we cancel out the t plus the r. Why would it switch from t minus r to r minus t?
Why would you do that? Why would you do that?
Why would I do that?
Is it because the alphabetical?
No, I'm just saying like see how it's t minus r, and then on the final answer you have r minus t.
Oh, my bad, my bad. It should be T minus R. I did alphabetical, yeah. See, I'm the one who thinks alphabetical. Yeah, you shouldn't. No, you shouldn't. Thank you very much. Which one you like? Division or ultimate LCD? for this one, it's just ultimate LCD, right? It's just not too bad. But when it comes to letters, when substitute number with letters, if you're good with multiplying fraction in your head, simplifying things in your head, for advanced students, or especially, you don't have to be advanced. Like you go to a higher course, you get used to these kind of things. So say when you go to calculus, you kind of like these better than the division, because you get better as you get older, hopefully. But yeah, for now, maybe step, you like division better. But when you go to calculus, you kind of like the second one 'cause it's faster. Yay, we did 1.4. It's a long section. Take a few minutes break and then we can continue 1.5. What time we done? 47. Thank you. One point five is short. It's only like a few pages. It's already.
send it twice, it double beat on the second offsite. You know, you have those. Because we were up here doing
Oh.
it together, so I think send it twice, so it double beat out.
Was it? Okay. Let me know. Email me. Okay. Show me. Oh, I didn't know it's double the amount. Okay, all right. Let's